Hello students, today we will talk about polar molecules, non-polar molecules and dielectric strength of any material. Look at this, we have thin jet of hexane, water and isopropanol. And what is happening when we bring charged ebonite rod close to it? As we can see, water jet and isopropanol jet gets attracted to the charged rod. It is responding to the static charge or electric field outside, and nothing is happening to hexane. Why it is so? So we can say that the water molecules or isopropanol molecules, they are reacting to external electric field, and then they must have something inside which can sense electric field. It may be dipole or its own field. So what is happening here? Let us check. There are some atoms or molecules in which the positive charge is at center. In all atoms we have positive charge at center. And what is negative charge doing? Negative charge is circling the positively charged center. And so if you are asked where is positive charge, we can say that positive charge is at center. And if we are asked where is negative charge, now negative charge is also moving around the center. So effective center of negative charge is also the same. And then such atoms or molecules don't possess any net dipole moment. So they don't have net charge, they don't have net electric field. Such molecules or atoms are called non-polar molecule. Okay, non-polar molecules means the molecules which don't have net charge or net electric field. But that is not so in some cases. In some cases, when molecule is formed, like in case of HCl, hydrogen is too small as compared to chlorine, and hence the center of positive and negative charge, they remain separated, as shown here. And then such molecules, even though they are electrically neutral, they do possess dipole moment, and hence whenever subjected to external electric field, they do respond. So the molecules which have net dipole moment are called polar molecules. Example: H2O, HCl, isopropanol, H2O2. These are example of polar molecules. See here, this is H2O2. Red one is oxygen, and two white spheres are indicating hydrogen. And as we can see, the hydrogen is too small compared to oxygen, and hence the charge distribution is not even. And that is why we have center of negative charge and center of positive charge separated. They are not at the same point, and because of that, such molecules possess dipole moment. And as we know, all the dipoles have their electric field in surrounding. So when we have thin jet of water, and if we bring charged comb or ebonite rod or any other source of static charge, static electricity, water does react to it, as we saw earlier. And that is true with H2O2 also. Hydrogen peroxide is also possessing net dipole moment. It is also polar molecule. Now, what happens to the molecule or atom which is non-polar but when subjected to external electric field? So here we have, say, some molecule which is having same center of negative and positive charge in absence of any external electric field. But now I want to subject it to external field. So see here in figure B, I am depositing positive charge on one side, negative charge on the other side, and so I can say that I have subjected the molecule to electric field. Electric field is not zero now. What will happen now? Now the positive charge of the molecule gets attracted towards the right side, and negative charge will move in opposite direction. And what happens as a result? As a result, we have center of negative and positive charges separated as shown here, and then we can say that now the molecule is possessing dipole moment. But remember one thing, this is the induced dipole moment. And as soon as you remember electric field, the dipole moment will again go down to zero. How much is the separation between the center of negative and positive charges? It depends on external electric field. More the field, more the separation. So dipole moment is directly proportional to the external electric field. Thus, when nonpolar molecule is subjected to external electric field, what happens? Dipole moment is induced. What happens to polar molecule when subjected to external electric field? It is already possessing dipole moment, and hence if you subject it to external electric field, it will simply rotate. And again, if electric field is too strong, here also we may find some change in the dipole moment. Now, when we put any molecule to external electric field, uh, as explained just now, we have dipole moment induced. But what happens if you increase strength of the electric field? What will happen now? So we know that the dipole moment will increase, separation increases means Q into 2A, 2A increases. So I can say that dipole moment has increased. But what if you deposit too much charge outside, means if strength of electric field is too much, what will happen now? If electric field is too much, then bond between the positive and negative charge will get broken, and then the molecule will break down. And when this happens, we experience spark in our wire, or spark when we touch some plastic chair or some silk cloth. In winter we experience spark, so at that time we see that the molecules are broken, and so spark is produced. So the electric field at which molecules of some material are broken is called dielectric strength of the material. Let us conclude now. So in conclusion, we can say that the polar molecules are the molecules in which center of positive charge and center of negative charge both are separated, and hence such molecules possess dipole moment. When subjected to external electric field, such molecules rotate because of the force experienced by positive charge and negative charge. On the other hand, nonpolar molecules are the molecules in which we have center of negative and positive charges at same point. They are coinciding, and so such molecules don't possess any net dipole moment. But if you put it into external electric field, they induce electric dipole moment, and as soon as you remove field, they will again become nonpolar molecule. We also saw that molecules give up if you subject it to too great value of electric field. The electric field value at which molecules break down is called dielectric strength of that material. So that was the topic. Thank you.